Hey guys, Nagraj here. Welcome back to my channel. If you are new for my channel, please do subscribe. Today we'll discuss about the differences between the ArrayList and LinkedList. This one is most commonly asked questions for freshers as well as those who are looking for the Java concept. So this will be the most important. In this video, we'll see the difference between the ArrayList and LinkedList as well as the similarity between the ArrayList and LinkedList before getting to the differences. If you understand how implementation done in ArrayList and LinkedList, it will be very easy for you to catch the differences between the ArrayList and LinkedList. Okay, the ArrayList and LinkedList, these two are classes, and these two classes implements the list interface. So ArrayList implements the list interface and LinkedList implements list interface as well as the DQ interface. So we'll see how exactly the implementation done in the ArrayList. So that will be easy for you to catch the differences between the ArrayList and LinkedList. Okay, let me go to the Eclipse. So I have created one class and I have declared ArrayList object. So if I declare ArrayList object here, so by default the Java will reserve 10 memory location to the ArrayList object. So suppose some value dot add. So as I have mentioned generics as an integer, let me add the integer value. Suppose I will add 10 now. Okay, so if I add value 10, how it memory will looks like? So it will be something like this. So ArrayList, the object will be created and it is reserving 10 memory locations by default. So remaining location will be empty, but it reserves the 10 memory locations. Okay, for the once you declare the ArrayList. Now the value 1 is added. So if I add more value, ArrayList dot, let me add some more values here. Let me add 2. Okay, I have added 10 integer value. So now how it will, initially it was like this, and after adding the 10 value, the array object will be looks like this. Okay, what happens if I add one more values here? Okay, so let me print out this. So let me print out this value ArrayList. Okay, if I run this program, so we get these values. So let me differentiate this. So get it more clarity. Okay, let me run this program. Okay, now these are the values. So if I try to add, suppose assume like, see, we have already 10 memory locations already reserved. What happens if I add one more values here? ArrayList dot add, let me add 11 here. Okay, what happens? So if I add 11th element, right? So memory locations, the ArrayList memory size will be increased by 50%. So it will be like this. Previously it was like that, right? 10 element what added. So after that, we have added one more value. Initially, ArrayList will be pointing to this memory location, correct? So once we add 11th element, so this memory location will point to the new memory location, which is having the new memory location area. Okay, so this will be taken care by the garbage location. So now the question will be how it is increasing the size by 50%. We have some formula for that. So let me go back to the. So this is the syntax to capacity. Okay, so let me add capacity here. Capacity of the memory locations will be, initially by default it will be 10. So new locations will be n into, here n is the current memory location element into divided by 2 plus 1. So if I calculate this one, right, so what it will be the output? So current value will be 10. Initially it was 10. Right, so star into 3. So now the value will be, it will come 16. So 16 will be the new memory location value. So if you consider here, after 10 the memory location increased by 50%. Now it will be 16, 0 to 15. So there are 16 memory locations are available now. Memory locations are reserved to the ArrayList. As the earlier memory locations will be taken care by the garbage collector, the new memory location looks like this. Okay, so memory location added to this, and previously whichever we declared for 10, that will be taken care by the garbage collectors. So now the new memory locations will looks like this. Let me explain quickly once again for the ArrayList how it works. So initially by default, once you declare the ArrayList, by default Java will allocate 10 memory location to the ArrayList object, right? Once you add the value 1, 2, 3, 4, 5 up to 10, once you add 11th element, it will increase the size by 50%. If I go to the array linked list here, so I have created already ArrayList, again the integer type, the generics have added integer, so I have added integer value, 10 values I have added. So if I run this, I can able to get the output. So let me run this. So linked list value, these are the value I got. So how it works internally. The difference between the ArrayList and linked list here, main difference is internal implementations. So each element here, if you see here, 10 element I have added, each element there are two nodes, one node and two nodes. So one node will be linked to the previous element and another node linked to the next element. What about the first element? The first node will be connected to the null value, and next element will be connected to the next element of this array. And what about the last element? Last element, one node will be connected to the previous element and next node will be connected to the null value. Okay, this is how the internally the data will be reside inside the linked ArrayList object. Okay, now it will be easy for you to differentiate between the ArrayList and linked list. Now we'll see one by one the differences between the ArrayList and linked list, so that it will be easy for you to catch. The ArrayList search operation will be faster compared to the linked list. Why it is so? Because even though if you see here, so I will go to the ArrayList. So we have an index concept. Suppose if I want to print out some particular value, I am searching some value here. So array of, suppose I want to display the second element. So directly I can add the index as 1. So if I add this value, right? Okay, this is the index value which I am going to explain now. So suppose I want to search this value. What is there in the second element, right? If I search this value, definitely I will get the value as an index value. The 2 I should get. The searching is very fast. We are using this index concept. We can able to search very quickly. But in case of linked list, right? It will try, as we have a doubly link in the sense we have a node concept, right? It will go and search first. It will go and search the first element, whether it is the searching element is there or not. Again, it will go for second element. By one, it will go and search. So that's why the search operation is slow compared to the ArrayList in case of linked list. Okay, the search operation of the linked list is slower compared to the ArrayList. So what about the delete operations? Delete operation is slower compared to the linked list here. Why delete operation is slower now? So if I go back to my previous example, so suppose if I want to delete this value, suppose if I want to delete third element, right? So once it is got deleted, now this will be shift operation will takes place. This 4 will go and sit here and 5 should go here. Yeah, this shift operation will definitely takes time, so that the ArrayList will be slower in case of linked list in terms of the delete operation. But in case of linked list, if I want to delete 5 here, right, the node of the fourth element will be connected to the next element. That's it. Now there is no shift operation will takes place here. So delete operation will be faster in case of linked list. So what about the insertion now? So insertion, again the ArrayList is slower compared to the linked list. Why it is slower? So ArrayList, if I want to add some value, so insert some value. Suppose I want to insert some value in between 4 and 5. I want to add some. In that case, 4 should go and 5 should shifted to the right. So here again the shifting operation should take place. Again the insertion will be slower in terms of the ArrayList compared to the linked list, right? In case of linked list, right, suppose if I want to add or if I want to insert some value, suppose let me add some value here. Suppose assume like I need to add value in between 4 and 5 element. Okay, so this one I have added. So anyhow, this should have the 2 nodes here. So this fourth element node should be connected to here, and finally this newly added node connected to the, so that's it. So there is no shift operation will take place here, so that we can say the linked list insertion operation is slower. The memory consumptions of ArrayList is lower compared to the linked list, because we have the doubly link concept we have in the linked list. So definitely the memory consumptions will be very high in terms of the linked list. So which one we need to choose finally, right? So whether we should go for ArrayList or linked list while coding. Based on the implementations of the ArrayList, as we saw, based on the implementation of ArrayList and LinkedList, we can able to choose like, okay, which one we should go. So wherever we have some search operations is more concentrating more, like if there is a less add or remove operations or search operations are more, then we should go for the ArrayList. And the requirement is like we need to delete or insert operations are more, so in that case we should go for the LinkedList. Performance will be higher compared to the ArrayList in terms of the deletion or insertion. So in this video we saw some of the similarities between the ArrayList and LinkedList and also the difference between the ArrayList and LinkedList. So in brief, we can say the ArrayList or search operations is faster compared to the LinkedList, and in terms of delete operations, the ArrayList is slower compared to the LinkedList. Insertion, again, it is slower and the LinkedList is faster. The memory consumptions of the ArrayList is low because we don't have any doubly link concept in case of ArrayList, but LinkedList we have each element having the two nodes, and one node is connected to the previous node and another node is connected to the next element, right? So the memory consumptions will be higher. So finally, whenever we have search operations more and very less we have remove and insertion operations, in that case we should go for the ArrayList. But in LinkedList, whenever we have deletion or insertion options more and search operations less, then we should go for the LinkedList. So hope this will be useful for you to understand the similarities and differences and also the internal implementation of ArrayList and LinkedList. Hope you understood all these concepts, and if you still have any doubt regarding ArrayList and LinkedList, please do write in comment sections. And finally, thanks guys, thanks for watching my video, and if you like this video, please hit like button and don't forget to subscribe my channel for further video. Thank you.